In this unit, we're going to learn how to figure out where two straight lines cross. And that can be a really important thing to know, especially if you want to go into an area like economics or business. You do a lot of this kind of math because you want to see how much supply and how much demand there is so that you can make the maximum profit. And so this is actually a really useful skill to have. There's a number of ways to do this. The first lesson I'm going to show you is how to do it by making a graph. And that means that we have to remember how to graph our lines. And so let's just have a quick look at that and refresh our memories before we start off. All right, if I look at the red line, y equals 2x minus 1, the way that we graphed that was we started at the minus 1. Remember that that number, the one that's just by itself, is always the starting point when you're graphing a straight line. The directions to get to the next point on the line, because we need 2 to draw a line, is we're going to look at the number 2 and we're going to make it into a fraction. So now it's 2 over 1. And the reason I did that is that this is actually your instructions to get to the next point. It's up 2, because 2 is on the top, and 2 is over 1. So if I start at the point we just put on, I'm going to go up 2 and over 1, and that's the second point that I need for my line. So I just join it up with a ruler. Rulers are really important in this topic because we have to know exactly where they cross. So for the other line, we have y equals 3x minus 3. That's our blue line. And so we can't see it down on the bottom here. It got cut off, but our starting point is here at minus 3 because that's this number at the end, right? That's what we call our y-intercept. And then making 3 into a fraction makes it 3 over 1. So we're going to climb up 3. So if we're starting down here at minus 3, it's going to bring us up to 0. And over 1, and that's the second point on our line. So there we go. We draw the blue line, and what we're really interested in here is how the blue line and the red line meet up. That's what we're trying to find. So that's this point right here. We call that an intersection. It's just where things cross. An intersection on roads is where two roads cross, maybe at a light or a stop sign. And so we can read that point from our graph if we go over 2 on the x-axis and then up 1, 2, 3 on the y. That's the point where they cross, and that's the only point that they both go through. And so we call that our POI, our point of intersection, and we write it as an ordered pair. Remember, x comes first and then y. It's just like the alphabet, x, y, z. And that's our point of intersection, and that's our solution. Here's the first example that we're going to do together. Let's go through the steps first of graphing the line. Please just ignore the little box here. I'm just trying to cover up a negative sign that made its way into the question, and it shouldn't have been there. So we have y equals 2x plus 2 and y equals 3x plus 3. So we need to graph both of these lines. With the top line, we're going to start at this number on the y. We're just going to put a point right there, simple as that. So the first point is free. We just have to take that number and put it right on the graph. The second point, we're going to change that slope into a fraction, so it's 2 over 1. And we're going to start at our old point. We're going to go up 2 and over 1. And that's where our line is going to be. So I have just tried to carefully draw a straight line through those 2 points as close as I can because this program doesn't let me use a ruler, or I haven't figured out how yet. And so now we're going to start on the second equation. Let's use a different color so we can keep track. Okay, so our purple line is going to start at positive 3, so that's the point at 3 on the y-axis right here. And then our slope is 3 over here, so it's 3 over 1 again. So we're going to count from the purple point up 3 and over 1. Remember, we always go to the right, never to the left when we're putting that point in. There, so now I have drawn the purple line, or second line on the graph, and like I said, as close to a straight line as I can. But if we take a look at our graph and we try to guess at where they were supposed to cross, and you'll be able to do this better than me because you have access to a ruler and a sharp pencil, it looks very much like they're supposed to cross, blue's not going to be good, right here. Okay, that's my best guess. It will always cross on the corner of a box, not in the middle. And that's why this method isn't used as often as some of the other methods you're going to learn, because if it's a fraction, it's very, very hard to tell what the fraction is. But it looks very much like the point -1, 0 is our POI, or our point of intersection for these two lines. And that's as far as we can go when we're using the graphing method. Here's another example for us to try together. So remember, we're always going to start at this number on the end. That's our b value, so it tells us where to go on the y-axis to put a point. And then our slope is 3/1, so our slope is up 3 and over 1. So if I go to -2, I like this grid better than the last one. It's got a little bit more space in it. That's my first point, and now I'm going to go from there 1, 2, 3 up and over 1. So I'm going to put a point right there, and I'm going to join those up with a straight line. So here's our straight line. We're going to label that with a 1. Oh dear, sorry about that. Let's just get it centered again. Okay, we're going to label that with a 1 for equation 1, and then let's try to do equation 2 in a different color. So we're going to do equation 2, and we're going to start with a b value of +3, and then our slope, which is our directions to the next point. So if you were standing on 3 and I said, hey, how do I get over to the point that's on this line? You would say, well, just go down 2 and over 1, because this is our instructions right here, and it's negative, so that means down 2 and over 1. So we're going to go down 2 and over 1. We start with 3, and from 3 we're going to count down 2, and then we're going to go over 1. Oh, look at that. So we landed right on the same point that we had on the pink line. That's fun, because we can definitely tell what the point of intersection is between these two lines now. There we go. Did you notice I figured out how to draw a straight line? So I've learned something today also. So here we go. That's equation 2, and we want to zero in on this important point where the two lines cross, and we would say the POI is or equals, doesn't matter which way you say it, and we have to go over 1 and up 1 to get to that point. So x is 1, y is 1, and that's where the two lines cross. For example 3, we've got two equations again, but there's a question being asked before we start, and it's a common sense check. In other words, we know something about these lines. We have some other knowledge that should help us to figure out where they're going to cross, maybe even before we graph it. Let's take a closer look at these lines. If I was trying to figure out what to put on the graph, then I would look at the last number, and that's my starting point, so that's b equals 5. And then I would look at my slope, and because there's nothing in front, I write a 1, and it's over 1. So my slope is 1 over 1, up 1 over 1. For the second equation, my b value is 5, and my m value is 2 over 1. Are you seeing what I'm talking about? Did you see it? If we have a look at what we just wrote out, look what happened with our b values. B is 5, B is 5. They have the same starting point. And isn't that what we're trying to find, is where these lines have the same point, because that's where they cross, right? So the common sense check is we don't actually need to do the graphing to prove it. We can see that they're both going to cross at the point 0, 5. So the first equation, 1, 2, 3, 4, 5, has a point at 5, and then it's up 1 over 1. And so our line goes through like that. That's equation 1. Let's skip to another color, and our second equation starts at 5 also, so we're writing right over our other point, so we know they have to intersect there, and its slope is up 2 over 1, so it can have the same y-intercept and a different slope. So that just makes it a little bit of a steeper line than the first one that we started with, and that's equation 2. So that was easy. We didn't even need to graph that one. If we caught that at the very beginning, we could have just said, hey, wait a minute, they share the same point. That must be where they intersect. For example 4, we're going to do exactly the same thing. We're going to add one more step at the end. So we're going to start with our y-intercept, which is our starting point for the first line, down 5 at -5. We're going to put a point right there. And then our slope is 4, which we know is 4 over 1. So we're going to go up 4 and over 1 to get to our second point. And then we're going to magically draw a perfectly straight line through that. Okay, so there's line 1, already graphed and labeled. This is great to get all of this practice on graphing straight lines. Our second line is y equals x minus 2. Just ignore the capital there. So our starting point for that line is -2. Let's change colors. We're going to go down to -2 on the y-axis, and that's our first point. Then we're going to go up 1 over 1, because there was no number written in front of the x. We know it's a 1. So we go up 1 over 1. Oh, look at that, it happened again. We landed on the exact same point that the black line had. And so we can clearly see that our point of intersection is over 1, down 1. So the point 1, -1 is where these two lines meet. I know I haven't drawn the second line on there. Let's just do a quick job of trying to fill it in so we have a complete graph. Okay, and we should always put the little arrows on the ends of our line. And that was equation 2. The one extra step that's included in this question that we haven't done before is to check your answer, especially when you're graphing, because you need a nice sharp pencil and a ruler to make sure that it's really, really accurate. And so you could be off a little bit. So here's how we check. If we're right that these lines both cross at 1 minus 1, then the point 1 minus 1 has to be on both lines. It has to work in both equations. So in equation 1, what we're going to do is a left side, right side check. Okay. So our left side is y, and our right side is 4x minus 5. We think y is minus 1, because that's what we got for our y value. And we think x is positive 1, so we're going to put it in place of x there and substitute. So 4 times 1 is 4, minus 5 is -1. The left side equals the right side, so we know that that point is definitely on line 1. For the second line, we're going to do exactly the same thing, left side, right side, and we have y, and we have x minus 2, and we think y is minus 1, and we think x is 1, and so we should get the same on the left as we do on the right, and we did. So now we know that our work is perfect before we even hand it in for marking. All right, I don't know if you've met Math Man before, but Math Man's superpower is doing math in his head, and I think that's a really awesome superpower. I wish I was as good as Math Man at doing that. And he's asking us a math question, and he's saying, is it possible for linear systems to have no solution? So a solution for two linear systems is where they cross, right? We're trying to always find the point where they intersect. So if we reword the question that he's asking, we could look at it as, is it possible that we could graph two lines and they would never intersect? Think about that for a second. See if you can picture in your mind what that might look like. I'm going to put a line on our graph just like this. And if I put another line on the graph anywhere else on this graph, is it possible that that line will never cross with my blue line? Can you think of one time where that would happen? I think any time that we have a line that runs exactly parallel to it, we're never going to cross, right? Because that's the definition of parallel lines. They're lines that never meet, right? And so if we have two lines that are parallel, we're not going to get a point of intersection. So don't think that you've done something wrong. Go and look at the slopes for your equation. And if the equations have the same slopes in them, so here we have a slope of 2, then they're going to be parallel. And that tells us that they'll never meet. So we should never find a point of intersection for those two lines. So now you're going to try the practice questions. When you've had a chance to try them all, check your answers, make sure that you got them all right and you understand it, and then you can move on to lesson 2.